All right, guys. Again, so I'm sorry I was pressed for time last time. We went over this, but let's go through this right now. I think the way it stopped was that I think I stopped at A. I had to take an important phone call. Let me just go through this. Exercise 2. It says at Arlington High School, 424 juniors recently took the SAT, right? On the math portion of the exam, the mean score was 540 with a standard deviation of 80. If the scores on the exam were normally distributed, answer the following questions. Right? What percent of the math score fall between 500 and 660? Well, in order for us to do that, we're actually going to have to subtract the 500 and the 660 from the 540. So, and divide that by the standard deviation. So we'll have 540 minus 500 over 80, which is going to give me 40 over 80, or 0.5. Sorry about that. That's 0.5, right? So we're trying to look at the percentiles. We're still not done. So we realize that it's 0.5 standard deviation. Remember the normal standard deviation, the normal curve, the normal Bell distribution curve. So that would be, so then we have 660 minus 540 over 80, which is going to equal 120 over 80, which equals 1.5. So we're at 1.5 sigma. Okay. 1.5 sigma. So that's 1.5 standard deviations. 1 second. Let me pause this for 1 second, guys, and pull up the curve. 1 second. Got to pull that up. 1 second. Sorry, guys. I'm back. Okay, guys, sorry. Just checking on that, all right? So right now we have the normal, here it is. This is the normal distribution curve, right? So this is what we're going to use as a reference for everything. All right, so if we go back to this right here, we're at 0.5 and 1.5. So it says what percent of the math scores fell between. So if we're looking at that normal curve distribution and we go 1.5 out in either direction, right? 1.5 out in either direction. 1.5 out in either direction right here. We're looking at between here. This one doesn't do a good job. 0.5 and 0.5. Let me find a better normal curve distribution, because one that you guys can see a little bit better. Here we go. This is better. Okay, this one's a little bit better. All right, so we essentially have at 0.5 we have, if you look at it, it's, you see how it's 0.5. I'm circled with the mouse. 0.5 in either direction is 19.1. All right, so we have to add those two probabilities up, those two chances up, and then from there we have to right? So, and then what else did it say? That was the 0.5. And then we want to do 1.5. So 1.5 is going to be 15. It's 1.5 above the mean, so it's 1.5. So it's 15 on top of that, right? So it's 0.5 below the mean, and it's 0.5 below the mean, right? So together, if we add everything up, right? So it's 9.2, 15, 19, and 19, right? We're left with 62.4. So we're left with 62.4. 62.4. We have to add up all the percentages. We say 19.1 plus 19.1 plus 15.0 plus 9.2. So B says, how many scores fell between 500 and 660? Round your answer to the nearest whole number, right? So we want something between 500 and 660. So then we look at a distribution curve. Or actually, we already found it. It was 62%. All right, so we need to get 62%. So this is 0.624 times how many students took the test? 424, which is an equal 265. Right, 265. So C says, if Evan scored a 740 on her math exam, what percent of the students who took the exam did better than her? So for that, we would have to say 740 minus 540 and divide that by 80. right? So, and we'll get 2.5, right? 2.5 is an answer, right? So you look at 2.5 standard deviations. So let's go back to this right here real fast. Okay. 2.5 is right here. So that means you have this much higher than her. So she did pretty well, 740. And D says, so you want to find okay, so that's easy. It's 0.6 times, 0.6 times 424, right? Which is roughly around 3. So this is 0.6. 0.6. Which is going to give you about 3. All right? Any questions on this?
This has a few meanings. As an adverb, it can mean
sorry.
the degree or extent
I don't know what's
indicated.
Katana. Anyhow, guys, I'm sorry. This is going all awry. But you guys can use this lesson as a reference, guys, and try to complete this sheet. Also, try to complete the back side of the sheet. It's all along the same lines. Just keep in mind that you do have to subtract from your mean and also divide by your standard deviation. All right. If there's no questions here, guys, any questions at all, guys, please don't hesitate to ask me. And then I will discuss with you. I will comment in the comment section, all right? Thank you, and I'll see you next time, guys. All right, see you.